Okay, let's unpack this. Today, we're diving deep into an idea that, well, it casts a really long shadow over the tech industry.
Mhm.
It's a concept that's both, aspirational and often, according to the sources we're looking at, fundamentally misleading. The 10x engineer.
Yes, the legend.
Exactly. They have the solitary coding virtuoso, the supposed rock star who can somehow just conjure code and solutions 10 times faster or better than their peers. It's this powerful, almost mythical figure, isn't it?
It absolutely is. And it's an idea that has really permeated how we think about talent, how companies structure teams,
Right.
and maybe especially how they approach hiring.
Yeah.
It puts this intense spotlight on finding these individual savants, kind of hoping they'll parachute in and
Yeah.
fix everything.
Yeah, hoping for a miracle worker. And our listener has shared some really compelling source material that meticulously examines and frankly challenges this very notion.
It does, very thoroughly.
So, our mission for this deep dive, based only on the insights presented in these sources, is to cut through the hype. We want to understand what truly drives speed, effectiveness, and, the ability to deliver value in software development teams.
Mhm.
This isn't about chasing unicorns, it's about rigorously investigating the system.
That's the crucial pivot, isn't it? The sources really move us away from that individual hero narrative.
Completely.
And they compel us to look at the environment, the culture, the tooling, the leadership, team structure itself, and, well, a lot more. It's about understanding the whole ecosystem, not just the individual plants growing within it, so to speak.
Good analogy. So, if the idea of a 10x engineer is, as these sources suggest, more myth than reality, or at least a severely oversimplified view, where did this powerful story even begin? How did it get so deeply embedded in our industry's thinking?
That's where we need to start, right? Tracing the origins laid out in the source material.
Hmm.
And they point back, well, quite a few decades, actually.
How far back?
Specifically to productivity studies conducted all the way back in the 1960s.
The 60s. Wow. That feels like ancient history compared to, modern cloud computing and agile methods. What were they even looking at back then?
Well, these were some of the very first attempts to actually quantify programmer productivity. Researchers were measuring things like the number of lines of code someone produced in a given time,
Right.
or the speed at which they could complete specific, pretty isolated coding tasks, or maybe fix certain bugs. And what they observed across various studies, people like Sackman, Grant, Knudsen are mentioned, was indeed a wide variance, a big difference in individual output among the programmers they studied.
Okay, so there was an observable difference. Some people were faster, clearly, even back then with the tools and techniques they had. But how did a study showing, say, a 5x or maybe even an 8x difference in a specific controlled task, how did that morph into this legendary fixed 10x figure that gets thrown around so broadly today?
Yeah, that's the fascinating part, the evolution of the myth as the sources describe it. Over the decades, these early, very specific findings seem to have been heavily extrapolated
Yeah.
and simplified, massively simplified in the popular imagination.
So the nuance got lost.
Completely. The detailed results from controlled experiments, which often depended heavily on the type of task being measured, these wide statistical distributions, they got condensed into a single, easy-to-digest, and frankly impressive number, 10x.
Catchy.
Very catchy. It became this potent shorthand for extreme individual performance, but it got detached from the specific context, the limitations of those original studies.
And it clearly resonated. I mean, how has this myth persisted and even thrived in the modern tech landscape, despite how complex software development is today?
Oh, it's incredibly prominent. It's deeply embedded in the DNA of startup culture, for one thing.
Right, the garage myth.
Exactly. That narrative of a small, intensely brilliant, almost superheroic founding team or early group of engineers building something revolutionary. It really resonates with the high-stakes, rapid growth environment of startups. There's this underlying idea that a few key individuals can single-handedly determine the fate of the whole company.
Like the lone genius coder mythologized over and over?
Precisely. That archetype is powerful.
Mm.
And it also connects, the sources point out, to the visibility of open source heroes. Individuals who make these massive, highly visible contributions to widely used software projects.
Oh, yeah. You see one name associated with a big framework.
Exactly. When you see one name frequently linked to a major framework or tool used by millions, it naturally creates this perception of immense personal impact and capability, even though realistically these projects are often the result of vast community effort over time.
You see Linus Torvalds' name and think, wow, one guy built Linux. But you forget the tens of thousands of contributors over decades.
Precisely that kind of simplification. And this perception, fueled by the myth, has had a significant and sometimes problematic influence on hiring practices. The sources specifically call out effing style hiring.
Right, the big tech interview gauntlet.
Yeah, referring to those often highly competitive, really rigorous, and sometimes heavily algorithmically focused interview processes at major tech companies. Now, the intention, presumably, is to find highly technically competent candidates.
Sure.
But these processes can sometimes feel like they're explicitly designed to identify candidates who fit that 10x mold. They focus intensely on individual problem-solving speed under pressure or abstract, isolated technical puzzles.
Rather than how they'd actually work on a team.
Exactly, rather than assessing collaborative abilities or how a candidate might actually function and contribute within a complex team environment day to day.
Okay, so putting aside the myth for just a second, when people use the term 10x engineer today, what are they usually trying to describe? Like, what are the actual underlying skills or qualities they're hoping to capture with that label, even if it's flawed?
That's a good question. Based on what the sources describe, the term is typically used as shorthand for several highly valued qualities in engineers. First, and maybe most often, it signifies deep technical expertise in a specific domain.
The specialist.
Right. This is someone who has a profound understanding of, say, database internals or kernel programming or maybe compiler design or large-scale distributed systems. They're the go-to person for the really thorny technical challenges in their area.
The expert who knows all the obscure corners of the tech.
Exactly. Second is often speed of execution or delivery, the ability to translate requirements into working, tested, and deployed code quickly and efficiently.
Just get stuff done fast.
And third is a high degree of autonomy, the ability to work independently. This is the engineer who can take a complex problem description and just run with it, figuring out the details, making sound technical decisions, and delivering a solution with minimal oversight.
Okay, those all sound like genuinely valuable traits. I mean,
Right.
any team would want engineers with deep expertise, speed, and autonomy, right?
Absolutely, no question.
But the source material argues that focusing primarily on these individual qualities, trying to find the 10x, is where the whole approach falls short. Why is that? Why is that individual focus the problem?
Because modern software development, especially in any organization of significant size or, with complex products, is fundamentally a team sport. It's just exceedingly rare that a single engineer writes, tests, deploys, and maintains an entire isolated application all by themselves anymore.
Right. Software systems are these huge interconnected things built by many hands, constantly evolving.
Precisely. They're complex, interconnected, and they require continuous collaboration across multiple people and often across multiple teams, focusing solely on maximizing individual output, which is what the 10x myth implies. Well, it fails to account for all those critical interdependencies.
Like, how does one person's code actually integrate? How do their decisions affect others?
It's exactly. How do their technical choices impact the rest of the system or the work of other teams down the line? How does the team collectively solve problems that no single person has the complete answer to? While individual skill is undoubtedly foundational, you absolutely need competent engineers. That's table stakes.
Of course.
The myth of the 10x individual distracts from the larger systemic factors that truly determine how fast, how reliably, and how effectively a team, and therefore the whole organization, can actually deliver value.
Okay, so that's a perfect transition. If we step back from the allure of the mythical unicorn engineer and look at the reality of collaborative software development, what are the real things that act as bottlenecks? What are the common, tangible sources of friction that actually slow teams down, regardless of how talented the individuals are?
This is the crucial shift in perspective that the sources really advocate for.
Yeah.
Instead of fixating on those individual performance differences, which, yes, they're real, but they often get overshadowed, leaders and teams should be diagnosing and addressing the impediments within the system itself. And the sources detail several specific, very common bottlenecks that act as a significant drag on team velocity.
Okay, let's dig into these real problems then. What's one of the most significant bottlenecks the sources identify?
One of the biggest, and I think often underestimated, is context switching.
Ah, the killer.
It really is. This refers to the significant cost incurred when engineers are constantly pulled between different tasks, different projects, or even just different types of work, like switching from deep feature development to fixing an urgent production bug, then jumping into a planning meeting, then trying to somehow get back into the zone for that feature work.
That sounds like the daily reality for so many engineers, juggling Slack pings, emails, code reviews, meetings, and somehow trying to get actual focused coding done in between.
Exactly. And each time you switch context, there's a cognitive penalty. It takes real time and mental energy to unload the previous task's details from your working memory and then load up the context for the new one.
It's not instantaneous.
Not at all. The sources emphasize that this constant interruption and multitasking significantly reduces overall efficiency and the ability to do that deep, focused work that complex problems require. You might feel incredibly busy bouncing between things.
Yeah, it feels productive sometimes.
But your effective output on any single complex task plummets, and often the quality of your work can suffer too. Think about trying to write a really complex piece of logic while, answering emails every 5 minutes. It's just incredibly inefficient.
Makes total intuitive sense. Okay, what's another key bottleneck? You mentioned unclear scope earlier.
Yes, this is a huge one. Problems arising from poorly defined project boundaries, ambiguous requirements, or goals that keep shifting midstream.
Oh boy.
Yeah. When the objectives of a task or a project aren't crystal clear, or if the requirements keep changing while development is already underway, engineers can waste enormous amounts of time exploring the wrong paths, building functionality that isn't actually needed, or having to constantly rework code they thought was finished when the scope finally solidifies or shifts again.
It's like starting to build a bridge without really agreeing on which river it's supposed to cross, or maybe changing the destination city halfway through construction.
That's a perfect analogy for the wasted effort and the frustration this causes. It's a massive drag on velocity because all that effort is expended, but it doesn't actually contribute to the final desired outcome.
Okay, what else? Inefficient communication.
Another major impediment highlighted is inefficient communication. And this isn't just about people not talking enough. It's more about poor communication pathways, maybe a lack of necessary information flow, or relying on ineffective communication methods.
So things like information silos, or just finding it hard to track down the right person to ask a crucial question.
Precisely. Information being locked away in specific individuals' heads, difficulty accessing documentation, or maybe the documentation exists but it's hopelessly outdated, relying solely on lengthy synchronous meetings for information that really could have been shared asynchronously through a document or a well-written ticket. All of this creates friction. Engineers constantly need information, make informed decisions, to understand dependencies, to just move forward. If getting that information is a struggle, everything can grind to a halt.
Yeah, imagine waiting hours or even days for a simple answer that unblocks your work. Multiply that across a whole team.
It's a huge productivity sink. Absolutely.
And then the sources point to more technical bottlenecks, right? Things in the delivery process itself, like inadequate CI/CD pipelines.
This is a huge one in modern software development. CI/CD, continuous integration, continuous deployment. If those processes are inadequate, if they're largely manual, or if they're unreliable, well, that creates significant delays and risks in actually getting code from a developer's laptop into the hands of users in production.
So if deploying code is this multi-day, manual, error-prone ordeal that requires coordinating across several teams, that's a massive friction point.
Massive. Instead of being able to deploy changes multiple times a day, maybe you're only deploying once a sprint, or even less often if it's painful enough.
Right.
And this slow, high-friction process means teams become hesitant to deploy frequently, which in turn delays feedback loops from users, makes it harder to fix bugs quickly when they do hit production, and generally slows down the whole pace of innovation and experimentation. A smooth, automated pipeline is pretty essential for high velocity today.
Makes sense. And the last one mentioned here was a lack of alignment across roles. What does that look like?
Yes, this happens when the different functions involved in the whole software delivery lifecycle, engineers, product managers, designers, QA specialists, operations, or DevOps folks, aren't fully aligned. They might not be working towards the same goals, or understanding each other's priorities, or even aware of each other's constraints and workflows.
So like the product team might be pushing hard for rapid feature delivery above all else, while the engineering team is deeply worried about growing system instability and technical debt, and maybe QA feels completely overwhelmed by the pace and lack of testing time.
That's a very common manifestation, yeah.
Yeah.
This kind of misalignment leads to conflicting priorities, misunderstandings, wasted effort because people are pulling in slightly different directions, and just a lack of smooth handoffs between the different stages of the process. Everyone might be working really hard,
Right.
but they're not necessarily working effectively together towards a single coherent objective.
Okay, so this whole extensive list of bottlenecks, the sources frame this from a leadership perspective, don't they? Arguing it fundamentally challenges how leaders should think about their role. How does it change the leader's focus?
It really requires a profound shift away from the traditional and often, frankly, ineffective approach of trying to maximize the output of individual engineers or spending all their energy trying to find and hire those mythical 10x individuals.
Right.
The sources argue that a leader's primary focus should instead be on understanding, diagnosing, and then systematically addressing these system-wide constraints and bottlenecks we've just been talking about.
So stop looking for the superhero to fly over the roadblocks and start actually dismantling the roadblocks themselves for everyone.
Precisely. Because the impact of fixing these systemic issues, reducing that context switching, clarifying scope up front, improving communication flow, building robust CI/CD pipelines, fostering cross-functional alignment, it has this compounding effect.
It helps everyone.
It benefits every engineer on the team, not just one supposed star. Addressing these friction points often unlocks a much larger, more sustainable increase in total team velocity than any conceivable gain you might get from boosting one person's individual speed. And this raises an important question that the sources really compel us to consider. How does the environment itself shape performance, even beyond these sort of tangible, process-oriented bottlenecks? What about the human side of things?
And here's where it gets really interesting, because the source material points to something that might seem, I don't know, less technical on the surface, but is presented as absolutely critical for achieving high velocity, the team's culture, and specifically psychological safety.
Yes.
It's presented not as being about individual heroics, but about the level of trust and safety within the group.
Absolutely. The sources introduce and really underscore the fundamental importance of psychological safety. And this isn't just, organizational soft skills fluff.
Right, it's not just be nice.
No, it's a concept backed by solid research showing its direct impact on team performance. The sources mention things like the famous Project Aristotle at Google.
Yeah, I remember reading about that. They studied their teams for years.
Yeah, exactly. And Google's multi-year research into what actually made their internal teams effective famously identified psychological safety as the single most important dynamic they found.
Wow. So what is it exactly in a team context?
Well, it means a shared belief held by the members of a team that the team is safe for interpersonal risk-taking. It's feeling safe enough to speak up, to ask potentially dumb questions, to admit mistakes when you make them, to challenge a dominant idea respectfully, to propose a different approach, or even to give difficult feedback, all without fear of being embarrassed, rejected, or punished for it.
Okay, so if I accidentally mess up a configuration change that takes down production for a minute, I feel safe immediately raising my hand and saying, uh-oh, I think I broke something. We need to fix this now so the team can swarm on it, instead of trying to hide it or fix it secretly, potentially making it much worse.
That's a perfect high-stakes example. Or even just on a daily basis, it's feeling comfortable admitting you don't quite understand a technical concept during a design discussion, rather than just nodding along and maybe later implementing something incorrectly because you were afraid to ask.
Yeah, okay.
Or being able to point out a potential flaw you see in a proposed architecture without worrying about being seen as negative or difficult or not a team player.
So why is this so crucial for velocity? How does feeling safe translate to moving faster?
Because it enables the very behaviors that are essential for complex collaborative work to happen effectively. It enables open and honest communication. It enables fast feedback loops on code, on ideas, on process improvements, and it enables effective collective problem solving, where everyone's perspective can actually be heard and considered, not just the loudest voice.
So information flows better, problems get surfaced faster.
Exactly. Teams with high psychological safety can identify problems faster, they can adapt more quickly to changing circumstances, they learn more effectively from failures instead of just assigning blame, and ultimately they make better collective decisions because information flows freely and people aren't holding back concerns or suggestions due to fear.
And the sources link other cultural elements to this too, right? It's not just safety and isolation.
Yes, absolutely. Closely intertwined are concepts like inclusive communication, really ensuring that diverse voices and perspectives within the team are genuinely heard and valued, not just the opinions of the most senior people or the most dominant personalities.
Right.
And fostering a genuine culture of learning, where when something inevitably goes wrong, The team's default reaction is to focus on understanding what happened and why the system allowed it to happen, viewing mistakes as crucial opportunities for improvement rather than just individual failures that lead to blame and punishment.
This paints such a different picture than that solitary 10x hero narrative we started with.
It's a complete contrast, isn't it? And the sources make this point very clearly. A single, incredibly skilled engineer, no matter how much individual output they can generate on their own, their potential will be severely hampered, limited in a toxic, low-trust environment.
Their brilliance gets bottlenecked by the bad environment.
Exactly. Their code might be brilliant in isolation, but if they can't get timely feedback on it, if they're afraid to point out potential integration problems with other people's work, if collaboration is stifled by fear or interpersonal conflict, or if making a mistake leads to public shaming, their overall impact on the team's ability to actually deliver value will be dramatically reduced. The friction of the negative system will negate much of their individual speed.
So they might still be hitting individual home runs, maybe, but the team isn't scoring runs consistently because they can't get on base reliably or move runners around the bases together.
That's a great analogy. Right. And conversely, the sources argue teams that do have strong psychological safety, where people genuinely trust each other, communicate openly, feel safe taking risks and admitting errors, these teams often achieve surprisingly high levels of velocity and resilience. They can collectively solve problems and adapt much faster than a team that's maybe relying on one or two perceived superstars, but operating in a fearful or fragmented environment. The team dynamic itself becomes this powerful engine for velocity.
So, for you listening, thinking about your own team, fostering trust and safety isn't just about creating a pleasant workplace, is it? According to these sources, it's a fundamental prerequisite for high performance and effectiveness for everyone on the team.
That is the core message coming through loud and clear. It's not a nice to have. It's presented as a foundational driver of performance in complex, collaborative work like software development.
Okay, speaking of enabling performance, the source material also places a huge emphasis on the role of tools. They're not just, things engineers use. They can be a significant force multiplier for the whole team.
That's absolutely right. The quality, the usability, the integration of the tools available to a development team. This can provide what the sources describe as invisible velocity.
Invisible velocity, I like that.
Yeah, these are gains in speed and efficiency that aren't about individual engineers magically working faster, but about the process itself becoming smoother, more reliable, and less prone to those manual bottlenecks and friction points.
Okay, so what kind of tools are we talking about here specifically?
The sources highlight several key categories. Think about things like effective code review systems, tools that make it easy, fast, and collaborative for engineers to review each other's code, provide really focused feedback, and integrate changes safely back into the main code base.
Right.
Incident response platforms, tools that streamline the whole process of detecting, diagnosing, communicating about, and ultimately resolving production issues, minimizing downtime, and reducing that critical metric, mean time to restore, or MTTR.
So tools that essentially make that core development loop, writing, reviewing, deploying, and fixing faster and safer for everyone.
Exactly. And crucially, the tools that underpin robust DevOps practices are absolutely key here. This means things like automation tools, automated testing frameworks at all levels, automated deployment pipelines, infrastructure as code tools that automate the provisioning and management of servers and services.
Automation takes the manual toil and risk out.
It does. Automation reduces manual work, eliminates human error in repetitive tasks, and allows changes to move through the pipeline quickly and reliably. Automated testing, in particular, seems critical for enabling speed without sacrificing confidence.
Yeah, the sources really highlighted that, didn't they?
They did. They point out that having a comprehensive suite of reliable automated tests provides the safety net, the confidence needed to make changes frequently and deploy them without excessive fear. Without that safety net, every change feels risky, which naturally leads to caution, slower movement, and bigger, riskier batch deployments.
Makes sense. What else on the tooling front?
Observability tooling is another key area mentioned. So tools for collecting and analyzing logs, metrics, and traces from your running applications in production.
So that helps you understand what's actually happening in production and troubleshoot things quickly when they go wrong.
Precisely. Understanding system behavior in real time, identifying performance bottlenecks before they become major issues, and diagnosing problems rapidly when they do occur. All of that is enabled by good observability. It directly contributes to faster problem resolution, lower MTTR, and also allows for proactive identification of areas that need improvement.
Got it. And one more. Internal developer platforms.
Yes. This is about providing self-service portals and tools for common developer tasks. Things like spinning up new microservices according to standard patterns, managing databases easily, accessing logs, and monitoring dashboards without needing special permission. This kind of platform unblocks development teams who would otherwise have to file tickets and wait on separate infrastructure or operations teams for these common needs. It reduces those external dependencies.
Okay, the source presents a really powerful comparison to drive this whole point about tooling home, doesn't it?
It does, yeah. It contrasts two scenarios. Scenario one, a capable, maybe just good enough engineer, technically solid, but perhaps not a superstar, working within an environment that's equipped with excellent tools and infrastructure. Think smooth CI/CD pipeline, comprehensive monitoring, easy access to resources, good collaboration tools.
Okay, and scenario 2.
Scenario two, a perceived 10x engineer, someone incredibly talented individually, but who's constantly battling outdated tools, manual and cumbersome processes, unreliable infrastructure, and just significant organizational friction to get anything done.
And the argument, which the source material strongly supports, is what?
The argument is that the good enough engineer operating within that well-tooled, efficient system will almost always outperform the supposed 10x genius who is fighting against a broken or difficult environment.
Really, even if the second person is individually much faster at coding.
Yes, because so much of that individual brilliance gets wasted just wrestling with the system itself, waiting for slow manual builds, debugging issues that better tooling would have caught automatically, fighting for access to basic resources, navigating bureaucratic deployment processes that take days. The tools in the infrastructure provide leverage. They remove systemic friction. A competent engineer, empowered by a smooth, well-designed system, can simply achieve far more net throughput than someone, no matter how smart, who's constantly swimming upstream against the current of bad tooling and process.
That really makes you think, doesn't it?
It does, and it raises a significant strategic question for organizations. According to the source, is the investment in building robust, usable tools and infrastructure actually a much better return on investment for achieving overall team velocity than the endless, expensive, and often futile search for these mythical individuals who are somehow supposed to be immune to the system's flaws?
It certainly sounds like a more scalable and sustainable approach, focusing on the environment, which leads us nicely into leadership's role. Moving beyond just tools, the source material makes it explicitly clear that leadership decisions are not just administrative overhead. They play a massive direct role in a team's velocity.
Absolutely. Engineering leaders are in a position to profoundly shape the environment we've been talking about. They make strategic decisions every day that either enable or inhibit a team's ability to move fast, effectively, and perhaps most importantly, sustainably. They aren't just managing people. They are, in effect, stewarding the system that their teams operate within.
So how do leaders directly impact velocity based on what the sources say? What are the key levers they pull?
Several key ways are highlighted. First, they significantly influence the sustainable pace of the team. Leaders manage workload, they set expectations around deadlines, they decide whether to prioritize aggressive, potentially burning out sprints, or to encourage a healthier, more sustainable rhythm of work. And the sources suggest that while those unsustainable pushes might yield very short-term bursts of apparent speed, they inevitably lead to burnout, reduced quality, increased errors, and ultimately, a significant slowdown in the long run. Maintaining a sustainable pace is presented as key to consistent, high velocity over time.
So pushing too hard isn't just bad for the people involved. It's actually bad for long-term velocity itself.
Invariably, according to this perspective, leaders also make critical decisions about managing technical debt.
Ah, tech debt. The gift that keeps on giving. Friction.
Exactly. That implied cost of future rework caused by choosing an easy, quick solution now instead of using a better, more robust approach that might take a bit longer up front. Leaders directly influence whether teams are given the time and resources needed to address existing technical debt, to refactor code proactively, to improve architecture, or if they're constantly pressured to prioritize only new features over that essential maintenance.
And the sources are clear on the impact of ignoring it.
Very clear. Ignoring technical debt might offer some perceived speed in the very short term, but it accumulates interest, just like financial debt. It inevitably becomes a massive source of friction and slowdown in the future, making every subsequent change harder, riskier, and slower to implement.
That debt always comes due, doesn't it? And usually at the worst possible time.
And it makes the whole system more brittle and fragile. Leaders also play a crucial role, the sources say, in meaningful prioritization. They are often the ones determining what the team works on and in what sequence. Clear, focused priorities are essential to prevent teams from scattering their energy across too many different initiatives at once.
Reducing that context switching again.
Exactly. And ensuring that the team's effort is directed towards most valuable work from a business perspective. A leader who can effectively communicate clear, stable priorities really unblocks the team to focus their energy and collaborate effectively on what matters most.
Okay, so those are the areas of impact. What about specific leadership practices that the source highlights as enabling high velocity? What does good leadership look like in this context?
The sources emphasize practices that build that trust we talked about earlier and streamline the flow of work and information. Transparency is called out as key leaders consistently keeping the team informed about broader company goals, strategic shifts, challenges, the why behind the work. This helps the team understand the context and make better local decisions that align with the bigger picture.
Makes sense.
Servant leadership is another concept highlighted. This is where leaders focus primarily on enabling their teams, removing obstacles that are slowing them down, providing the necessary resources and support, and fostering their growth, rather than just directing tasks or micromanaging execution details.
So, clearing the path and empowering the team to walk it effectively.
Exactly that. And finally, actively fostering strong cross-functional collaboration. This involves leaders deliberately working to build bridges and establish smooth, low-friction workflows between their engineering teams and other essential departments like product management, design, marketing, sales, support.
Breaking down those organizational silos.
Precisely. Removing those silos and ensuring everyone involved in delivering value is operating with shared context and towards common goals. That reduces friction significantly and accelerates the delivery of value end-to-end, not just within engineering.
It really sounds like effective leadership, from this perspective, is less about being the smartest individual engineer in the room and much more about being the person who creates the conditions for everyone else on the team to be effective together.
That's a great way to put it.
It's like they create the environment where all these other factors, the culture, the tooling, the team design, can really thrive and scale.
That is precisely the conclusion drawn from the sources. Leadership isn't just one factor among many. It's presented more like the orchestrator, the conductor that ensures all the other elements contributing to velocity are in tune and working together harmoniously and effectively.
And speaking of orchestration, the source material also points out it's not just about who is on the team, but how the team is actually structured and designed. It delves into team composition and design principles.
It does, yeah. Highlighting how intentional team design can proactively build velocity right into the structure. The core idea presented is to compose and structure teams in a way that minimizes their external dependencies and maximizes their autonomy to deliver value end-to-end for their specific area of responsibility.
Okay, how does the composition of a team achieve this? What does a well-composed team look like?
It's about aiming for a balanced composition within the team itself. This means intentionally bringing together the necessary mix of skills and expertise required for that team to complete its designated work without constantly needing to rely on people or teams outside of its direct control.
So including different roles within the team boundary.
Exactly. Depending on the team's mission, this could include back-end developers, front-end specialists, maybe an embedded QA person, a dedicated product representative, perhaps someone with strong DevOps or infrastructure skills if they own their own operations to some extent.
So for example, if a team frequently needs database schema changes to deliver their features, they ideally have someone on the team who can handle that safely and efficiently, rather than having to file a ticket with a separate central database team and wait in a queue.
Precisely. That directly reduces those dependency bottlenecks. When a team has most of the skills and ownership needed for its core work contained within its boundaries, it can achieve what the sources refer to as asynchronous flow.
Asynchronous flow.
Yeah, meaning different team members can often work in parallel on different parts of a feature or project without constantly blocking each other or needing synchronous handoffs and coordination with external groups. This dramatically speeds up that internal loop of development, testing, and integration within the team.
Gotcha. And the sources also emphasize the importance of role clarity within that team structure, right? It's not just about having the right skills, but knowing who does what.
Yes, role clarity is presented as crucial for efficient internal team functioning. It means ensuring that every member of the team clearly understands their primary responsibilities, their areas of ownership, and maybe the boundaries of their contributions as well.
So everyone knows what they're accountable for and where they should be focusing their energy day to day.
Exactly. When roles are clear, team members know who the best person is to go to for specific questions or expertise. They know where they should be primarily contributing their own skills, and they understand when they might need to take the lead on a particular task or decision within their domain.
And how does that clarity help avoid slowdowns?
Well, it helps prevent that kind of internal confusion and churn.
Okay.
The wasted time and effort spent just trying to figure out who is supposed to be doing what.
Mhm.
Or, maybe worse, two people accidentally doing the same piece of work because of ambiguity, which is pure waste.
Right. Duplicated effort.
Or the opposite problem. Critical tasks falling through the cracks because everyone assumed someone else had it covered. Clear roles minimize both of those failure modes.
What's really fascinating here is how thinking about team design and role clarity up front can act almost as a preventative measure. It removes potential sources of friction before they even have a chance to slow the team down.
It absolutely is presented that way. It proactively prevents the need for individuals to perform heroics just to navigate internal organizational complexity or ambiguity. A team that is intentionally designed for autonomy, with a clear mission and clear roles for its members, can achieve high velocity through smooth internal collaboration and minimized external dependencies.
Rather than needing a supposed superstar to somehow cut through bureaucratic red tape or constantly pick up the slack for underlying organizational inefficiencies.
Exactly. The system itself is designed for speed.
Okay, all this discussion about achieving velocity naturally leads to the question of how we actually measure progress. The source touches on metrics, and it gives a pretty strong warning about using the wrong ones, doesn't it?
It does. This is a really critical section in the source material, I think. Velocity is obviously a commonly tracked metric, particularly in agile methodologies. But the sources highlight that many traditional ways of measuring it can be easily gamed, or, even worse, can actively incentivize counterproductive behavior from teams.
Like focusing solely on things like story points completed per sprint. Is that the kind of thing they warn against?
Yes, that's a prime example. The sources offer a strong critique of metrics tied solely to story points, or maybe lines of code written, or other purely output-centric KPIs. The fundamental problem they identify is that these metrics can easily become targets in themselves, completely divorced from the actual value being delivered to users or the business.
Right.
Teams might, consciously or unconsciously, start inflating their estimates on story points just to show a higher velocity number on the team dashboard. Or they might prioritize churning through lots of small, easy tasks quickly, because that looks good on the chart, rather than tackling the larger, more complex work that might be strategically more important but yields fewer points in the short term.
It sounds like it encourages looking busy rather than being truly effective or strategic about the work.
That's exactly the danger pointed out.
Yeah.
It can create pressure for what the sources might call performative work activity that makes the team look productive on dashboards and reports, but doesn't necessarily translate into meaningful progress towards desired outcomes. It focuses everyone on optimizing the proxy metric, like points or lines of code, rather than the actual result we care about.
Okay, so if those are the potentially problematic metrics, what healthier measurements does the source suggest? What should teams and leaders be tracking instead to get a real understanding of true velocity and effectiveness?
The sources strongly advocate for shifting the focus towards metrics that reflect the actual flow of value through the system and the operational health and reliability of that system, rather than just measuring raw output volume. They highlight several key metrics often associated with DevOps and continuous delivery practices.
Okay, like what?
3 key ones are emphasized repeatedly. First, deployment frequency. Simply, how often does a team successfully release code to production? This isn't just a measure of raw speed. It's presented as a strong indicator of the overall health and reliability of their entire release process, their level of automation, and their confidence in the quality of their code. High deployment frequency usually implies that the pipeline is smooth, the tests are robust, and the team is effective at getting changes out safely and quickly.
So instead of measuring how much code was written, you measure how often working code actually gets into the hands of users.
Precisely. That's the outcome we care about.
Mhm.
Second, mean time to restore, MTTR. This measures how quickly, on average, a team can recover from a failure or an incident in production.
Okay.
This is highlighted as a critical measure of the team's resilience, their operational capability, and their understanding of the system they run. A low MTTR indicates that when something inevitably goes wrong, because it will in complex systems, the team is effective at quickly identifying the problem, diagnosing it, and implementing a fix. It measures their ability to minimize the impact of disruptions on users.
So it shows how effectively they handle the unexpected, which is a huge part of maintaining overall speed and reliability in the real world.
Right. And third, lead time for changes. This measures the total time it takes for a code change to go from the moment a developer commits it to version control all the way through the process until that change is successfully running in production and available to users.
So that captures the whole pipeline.
Exactly. It captures the entire flow efficiency of the team, the time spent coding, testing, reviewing, waiting in queues, deploying. A shorter lead time generally indicates a more efficient overall process.
Okay, so these three metrics, deployment frequency, MTTR, and lead time for changes, they seem to measure the speed, reliability, and resilience of the entire process from idea to production, rather than just focusing on individual activity within that process.
That's exactly the point the sources make. They strongly advocate for tracking these types of metrics because they provide a much better, much less easily gained insight into the actual effectiveness and efficiency of the entire system the team operates within. They track the team's ability to deliver value reliably and quickly. They shift the focus from simply measuring busyness or individual output towards measuring the speed and health of the value stream itself.
That makes a lot of sense. Now, if the whole 10x engineer myth focuses on finding these rare, supposedly irreplaceable individuals who generate exceptionally high output, how does the source material suggest companies should rethink their approach to hiring and talent acquisition if that myth is misleading?
It really requires a fundamental reorientation of the hiring goal. Instead of engaging in that often elusive and frustrating search for mythical, supposedly irreplaceable individuals, the kind where the company lives in fear of what would happen if that one person left.
Right, the bus factor of one.
Exactly. The sources argue that the focus should shift entirely. It should be towards hiring people who demonstrably enhance and amplify the capabilities of the entire team they join.
Okay, that sounds like what the source calls hiring for team amplification. What does that actually mean in practice?
That's the core concept, yes. It means actively looking for individuals whose contributions don't just stand out in isolation, maybe on a whiteboard problem, but whose skills and behaviors actively make everyone else on the team better and the team's collective process more effective and sustainable.
Interesting. So what kind of qualities, besides just raw technical skill, become really important when you're hiring for this team amplification factor?
The sources highlight several qualities that directly improve the collaborative environment and the sharing of knowledge within the team. This includes, for example, engineers who consistently write readable, maintainable, and well-tested code.
Why is that a team amplifier? Seems like just good practice.
It is good practice, but it's an amplifier because code isn't written in a vacuum, right? Other team members need to be able to read it easily, understand it quickly, debug it when necessary, and build upon it confidently in the future. Clear, well-structured, well-tested code makes the whole team faster and reduces friction down the line.
Okay, so code quality isn't just a personal standard of excellence. It's actually a team efficiency multiplier. Got it. What else?
Individuals who are willing and demonstrably able to mentor and help others grow are huge amplifiers. They don't just contribute their own work. They actively raise the overall skill level and capacity of the entire team over time. That's a massive force multiplier.
Yeah, spreading the knowledge.
Absolutely. People who document things well, designs, processes, decisions, are also force multipliers because they share knowledge effectively and scalably, reducing dependence on any single person's memory and making it much easier for new team members to get up to speed quickly.
Reduces bottlenecks.
Exactly. And engineers who actively work to improve communication within the team, whether that's through clear writing and code reviews, effective explanations during technical discussions, or facilitating better collaboration practices that reduce friction, improve shared understanding, and just make the whole team function more smoothly.
It sounds like all these qualities are about improving the function of the system, the team, not just optimizing the performance of one individual component within it.
That's exactly the shift in perspective. And the sources provide some guidance on how to actually identify these qualities during the hiring process itself. It means intentionally designing interview processes and evaluation rubrics that go beyond purely assessing individual algorithmic problem-solving speed or performance on isolated technical puzzles.
So instead of just asking someone to, say, invert a binary tree on a whiteboard under pressure, You may include things like pair programming exercises to see how they actually collaborate and communicate while coding, or ask them to review a realistic piece of code and explain their feedback clearly. Or maybe ask behavioral questions about how they've handled technical disagreements or helped a teammate overcome a challenge in the past.
Precisely those kinds of approaches.
Hmm.
It's about designing interview scenarios that allow candidates to actually demonstrate their ability to collaborate effectively, communicate clearly, teach others, learn from feedback, and think about the impact of their work on the broader system and the team, alongside, of course, assessing their core technical competence. You still need that.
Of course.
But it's a real contrast with hiring methods that seem laser-focused solely on finding individuals who shine brightest when working completely in isolation. The most valuable hires, according to this perspective presented in the sources, might very well be the ones who don't necessarily fit that narrow, mythical 10x mold, but who consistently make the entire team around them stronger, faster, and more effective.
This whole perspective shift sounds incredibly valuable, but does the source offer any concrete illustrations? I know we don't have the full case studies in front of us, but what kinds of real-world examples does the source suggest actually validate this idea that velocity comes from optimizing the system, not just finding individual rock stars?
The source does indicate that it provides case studies and examples to demonstrate this approach in practice. And while, as you said, we don't have the full details of those specific companies or situations here, the source describes the nature of these examples pretty clearly to illustrate its points.
Okay, great. So what kind of stories are these, generally speaking?
Well, they're presented as examples of companies or specific teams achieving remarkably high levels of velocity, reliability, and effectiveness within their industry or domain. Results that, frankly, could not realistically be attributed to simply having one or two supposed superstar engineers carrying the whole load.
Right, the scale of achievement points to something systemic.
Exactly. The examples referenced are described as things like, say, a health tech firm that significantly reduced its overall lead time for changes and dramatically increased its deployment frequency, getting features and fixes out much faster. The source suggests this was achieved primarily by systematically optimizing their deploy pipeline, implementing robust automated testing across the board, and improving their infrastructure automation.
Okay, so that sounds like a clear victory for improving tooling and process, not finding a magic bullet engineer.
Exactly. That's how it's framed. Another type of example mentioned is described as a fintech company that managed to dramatically improve its onboarding time for new engineers, getting them productive much faster, and saw a significant increase in overall team output shortly after. The source indicates this resulted from consciously rethinking their team structure for better autonomy, significantly improving their documentation and knowledge-sharing practices, and fostering a more explicit culture of mentorship and shared ownership.
Right, so that sounds like a win based on improving team design, culture, and internal processes. Again, systemic changes.
Precisely. Not just hiring a few supposedly magical individuals and hoping for the best.
It sounds like the common thread running through these examples, at least as described in the source, is a focus on shared practices, better collaboration, and improving the overall work environment for everyone.
Absolutely. The source highlights that these successful teams, the ones achieving high velocity sustainably, often exhibit consistent engineering practices across the board. They tend to cultivate a culture of low ego, where individuals seem more focused on the team's collective success than on personal accolades or being the hero. And they emphasize shared ownership of code, architecture, and outcomes, rather than relying on individual heroes to swoop in and fix problems or carry disproportionate loads.
That makes perfect sense. The results come from the collective, the whole team adopting better ways of working, supported by an environment that actually enables and encourages those practices.
Right. The core lesson illustrated by these types of examples, as presented in the source, is that significant, sustainable, and scalable results in software development really come from that collective effort and the well-tuned system that engineers operate within. They serve as proof points that no single individual, no matter how talented they might be in isolation, could possibly achieve that level of organizational velocity alone. It's the team, empowered by its environment, that truly drives the performance.
Okay, so bringing this all together, what does this deep dive into the source material really mean for you, the listener, navigating the world of tech teams, whether you're an engineer on the ground, a team lead, maybe a product manager, or even higher up? We started by examining that powerful, persistent myth of the 10x engineer. We've systematically unpacked it, and Based only on the sources provided to us, we've explored what actually seems to fuel high velocity and effectiveness in software development teams.
And we've seen pretty consistently throughout the source material that while individual competence is obviously necessary, it's the starting point. The major levers for improving speed, reliability, and the ability to deliver value consistently are systemic.
Right.
They lie in things like building a culture of psychological safety and trust, where people feel safe enough to truly collaborate and learn together. Investing in effective tools and infrastructure that act as genuine force multipliers for everyone. Cultivating strong, servant leadership that focuses on removing obstacles and setting clear, focused priorities. Intentionally designing teams for autonomy and role clarity, and critically, shifting the focus of measurement towards what truly matters, the flow of value and the health of the system, not just vanity metrics of individual output.
The source's concluding message seems really clear and, frankly, quite compelling.
Yeah.
That myth of the 10x engineer, while it's simple and maybe appealing on the surface, is ultimately misleading, mostly because it distracts us from the complex, interconnected reality of how high-performing teams actually function and what makes them successful.
It is. But the truth, as it's presented in the source material we reviewed, is arguably far more empowering in the long run. Velocity and effectiveness don't come from desperately trying to hire a few supposedly superhuman individuals who may or may not even exist, and whose impact is rarely sustainable or scalable anyway.
Yeah.
Instead, they come from the achievable, tangible daily work of building better systems, fostering intentional culture, providing great tools, and empowering entire teams to collaborate effectively.
It really shifts the perspective, doesn't it? From this frustrating, often fruitless search for irreplaceable unicorns to the more practical and, I think, ultimately more empowering goal. Building environments where every engineer can be a force multiplier, where the collective creativity, skill, and effort of the whole team, enabled by a healthy system, creates performance that far exceeds the simple sum of its individual parts.
Exactly. It means focusing your energy on improving the soil and the climate, not just searching endlessly for the single most impressive individual plant to put in it.
That's a really powerful reframing. So here's a final thought for you, the listener, based on everything we've explored from the sources today. If building the right environment and improving the system allows every engineer to contribute more effectively and raises the overall team velocity, what are the first small steps you could identify and potentially take, starting today within your sphere of influence, on your team, or in your organization to improve the system around you, rather than just waiting for a hero to show up and fix everything?
Maybe just look for one recurring point of friction you experience regularly, whether it's a communication gap, a clunky tool, or constantly unclear requirements, and just consider what one small systemic change might begin to alleviate it, even just a little bit for everyone.
Because even a small improvement to the system can ripple through the whole team's effectiveness over time. That's definitely something worth thinking about.